The universe has existed for 13.8 billion years. It is incomprehensibly vast, breathtakingly beautiful, and if you really think about it, absolutely terrifying. Why? Because when you look up at the night sky, you're looking at a profound, mathematical impossibility. A chilling paradox of total cosmic silence. Welcome to the greatest mystery of human existence. We call it the Fermi Paradox. And the numbers behind it will keep you awake at night. Let's start with the hard scientific facts. In our observable universe alone, astronomers estimate there are up to 2 trillion individual galaxies swirling around. But let's just zoom into our own cosmic backyard, the Milky Way. This single galaxy contains roughly 400 billion glowing stars. Thanks to data from NASA's Kepler Space Telescope, we now know that almost every single one of those stars hosts at least one planet. Out of those, scientists estimate there are up to 40 billion Earth-sized planets sitting perfectly in what we call the habitable, or Goldilocks zone. This is the optimal region around a star where conditions are not too hot and not too cold, allowing liquid water to pool on the surface. With billions of years of cosmic history, even if life forms on a microscopic fraction of these worlds, our galaxy should be teeming with civilizations. By all mathematical and statistical logic, our cosmic neighborhood should be buzzing with alien radio signals, towering interstellar megastructures, and endless cosmic traffic. Yet, nothing. We have pointed our telescopes at the stars for decades, and we have found absolutely nothing. Just the profound silence of the void. In the summer of 1950, brilliant physicist Enrico Fermi looked up at the night sky during a lunch break and asked one simple, chilling question. He asked his colleagues, "Where is everybody?" It is a forward question that has haunted astrophysicists, philosophers, and astronomers ever since that day. If the universe is a giant cosmic lottery, humanity shouldn't be the only winner. To solve this, scientists created a mathematical tool to calculate the odds. It's known as the Drake equation, and when you finally plug the cosmic numbers in, the results lead to some deeply disturbing conclusions about our existence. In 1961, at the Green Bank Observatory, astrophysicist Frank Drake hosted the first meeting to search for extraterrestrial intelligence. He needed a way to frame the debate. So, he wrote down an equation. It wasn't meant to give an exact number, but to organize our ignorance. It calculates in the number of communicating civilizations. The first variables are astronomical facts. How fast do stars form in our galaxy? We know this. It's about 1.5 to 3 new stars every single year. Next, what fraction of those stars have planets? And how many of those planets sit in the habitable zone? Thanks to modern telescopes, we know planets are incredibly common. But here is where the science turns into hypothesis. What fraction of these perfect, watery worlds actually manage to spark life from non-living chemistry? And if simple life does emerge, what are the odds it evolves into complex, intelligent beings capable of building civilizations, rather than just remaining as cosmic algae? Even if they get smart, they must develop technology that releases detectable signals into space, like radio waves or lasers. A dolphin is smart, but it won't build a radio telescope. Then comes the final and most terrifying variable, L. The length of time an advanced civilization releases those signals before they disappear. How long does a technological species survive before they exhaust their resources, trigger a planetary catastrophe, or quietly fade into the cosmic dust? If you're an optimist like Carl Sagan was, you might guess that civilizations survive for millions of years. In that scenario, the Milky Way should have thousands of alien neighbors. But if you're a pessimist, you plug in lower numbers, and the math spits out a chilling result. The number of civilizations in the galaxy right now is just one: us. This profound contradiction between the high probability of life and the absolute lack of evidence creates a massive, unsettling void in our understanding of reality. If creating life is a natural cosmic process, why isn't the universe a bustling empire? Many scientists believe there is a hidden, insurmountable barrier, a universal hazard so deadly and inevitable that almost no species can survive it. A stage in evolution where everything simply stops. In 1998, economist Robin Hanson gave this terrifying concept a name. He called it the Great Filter. The Great Filter hypothesis suggests that somewhere along the evolutionary timeline, there is an incredibly difficult step, a terrifying cosmic barrier. It is a highly improbable evolutionary leap that almost no species can successfully cross. It acts as a universal, silent exterminator. This leads to the most important question in human history. Have we already passed the Great Filter, or is it waiting for us? Let's look at the optimistic scenario. The filter is firmly behind us. This means humanity has already survived the absolute hardest part. Perhaps the barrier was the incredibly rare transition from simple single-celled organisms to complex, multicellular life forms with a nucleus. On Earth, life started very quickly, but it remained as nothing more than primitive, floating biological sludge for nearly 2 billion years. Getting two cells to cooperate was a microscopic miracle. If this is the filter, the universe is full of bacteria, but no spaceships. In this scenario, we are the lucky outliers. We are the exceptionally rare champions of a nearly impossible galactic biological lottery. But what if the filter isn't behind us? What if the absolute hardest part of survival is still waiting somewhere in our future? This is the terrifying scenario. It implies that getting smart is easy, but surviving your own technological adolescence is mathematically almost impossible. Advanced civilizations might inevitably trigger their own collapse. Runaway environmental degradation, depleted resources, or uncontrollable experimental technologies fading them silently into dust. This is exactly why philosopher Nick Bostrom famously stated that finding simple life on Mars would be the absolute worst news in human history. If we discover fossilized bacteria on Mars, it proves starting life is incredibly easy, which means the Great Filter must lie ahead of us. It would imply that the silence of the galaxy is actually a massive graveyard of fools, and we are just next in line to fade away. So are we doomed? Or is there another explanation? What if Earth is just uniquely blessed with a bizarre, impossible set of perfect conditions? In the year 2000, two scientists proposed a controversial idea. They argued that the Drake equation is deeply flawed and vastly over-optimistic. Peter Ward and Donald Brownlee introduced the rare Earth hypothesis. It states that while microbial life might be common, complex life is a statistical impossibility. Let's start with our address. Earth sits perfectly in the galactic habitable zone, too close to the galactic core, and deadly radiation sterilizes everything. Too far out on the galactic edge, and there aren't enough heavy elements to form rocky planets. We live perfectly in the cosmic suburbs. Then, there is the bizarre architecture of our solar system. We have a massive gas giant, Jupiter, orbiting at exactly the perfect distance. Jupiter acts as a gigantic gravitational vacuum cleaner. Its immense gravity constantly sweeps up and deflects dangerous comets and asteroids away from the inner planets. Without Jupiter constantly taking the hits, Earth would be struck by extinction-level impacts far too often for complex life to ever have a chance. Next is our Moon. It is abnormally large compared to the size of our planet. No other rocky world in our solar system has a companion like this. This massive moon acts as a crucial gravitational anchor. It stabilizes Earth's axial tilt, preventing wild, chaotic climate swings that would wipe out ecosystems. Deep inside, Earth hides another incredibly rare engine, a rapidly spinning liquid iron core. This generates a powerful magnetic shield extending far into space. Without this magnetic field, the relentless and deadly solar winds would have stripped away our atmosphere billions of years ago, leaving us completely barren. Even our crust is a rare miracle. Active plate tectonics constantly recycle carbon deep into the mantle, acting as a global thermostat that regulates our climate. If you remove even one of these features, Jupiter, the Moon, the magnetic field, or tectonic plates, Earth would instantly transform into a dead rock like Mars. The rare earth hypothesis suggests we didn't just win a biological lottery. We won an astronomical, geological, and cosmic lottery all at exactly the same time. So maybe we truly are alone. But what if we aren't the first? What if countless ancient civilizations rose to glory, only to quietly fade away? The universe is unimaginably old. But what if the lifespan of a technological civilization is tragically, heartbreakingly brief? Consider Earth. Our planet has existed for 4.5 billion years. Yet, humanity has only possessed radio technology for about a single century. In the cosmic scale, our radio signals have formed a bubble that is barely 100 light-years wide, a microscopic drop in a galactic ocean. If an alien empire is watching Earth right now from the other side of the galaxy, they don't see our cities. The light reaching them shows dinosaurs. This brings us back to the L variable in the Drake equation, the lifespan of a communicating civilization. And it might be the saddest number of all. Advanced species require massive amounts of energy. They might inevitably consume their planetary resources completely before they ever learn to travel the stars. Or perhaps they trigger runaway environmental collapse, a once vibrant world quietly suffocating under a self-made, toxic greenhouse atmosphere. Instead of a violent, fiery end, a civilization might simply power down, their techno-signatures fading into the dark as their technology slowly decays. Even if thousands of civilizations do exist, time is the ultimate, unbreakable barrier. We call this the window of communication. Species might rise and fall like fleeting sparks in the dark. Two galactic empires could exist, but miss each other by millions of years. We might be actively searching for neighbors who have been dead for eons. We are just listening to the echoes of ghosts. The galaxy could be filled with silent, decaying megastructures, giant, rusted monuments to species that lost their race against time. The profound silence we hear through our telescopes isn't because the universe is empty. It could be the terrifying silence of a cosmic graveyard. If civilizational fate is the final answer, then our current, brief window of existence is a fragile, temporary miracle that we must fiercely protect. But there is another theory, a darker one. What if they aren't dead? What if they are out there right now, listening, and choosing to hide? To understand the dark forest theory, you must change how you view the universe. Stop looking at it as an empty room, and start looking at it as a dark, terrifying forest. In this forest, every surviving civilization is an armed hunter stalking through the trees like a ghost. They must be completely silent. They must remain hidden. Because of the vast distances of space, communication takes years or centuries. This creates an unbreakable chain of suspicion in game theory. You can never truly know if another civilization is peaceful or aggressive. And if you wait to find out, it might cost you your entire species. In the dark forest, survival relies on one simple, terrifying rule. If you reveal your position, you will be eliminated. Imagine a young, naive civilization. They invent radio. Filled with hope, they broadcast a powerful signal out into the stars, shouting, "We are here!" To an advanced hunter, that signal isn't a greeting. It is a set of coordinates. And the only logical response is a silent, preemptive strike. Because if you don't destroy them first, they might eventually advance and destroy you. It's not out of malice. It is purely mathematical survival. This is why the universe is perfectly silent. The galaxy isn't empty. It is packed full of advanced civilizations. But they are all holding their breath. And then, there's us, humanity. For over 80 years, we have been blindly screaming into the dark forest. We haven't just leaked TV and radar signals. We have intentionally aimed massive radio telescopes at star clusters and fired messages directly at them. If the dark forest theory is correct, these attempts at contact are the most dangerously foolish actions in the history of our species. We are walking through a jungle full of sleeping predators, striking a match, and yelling to see if anyone is awake. This implies that the Fermi Paradox isn't a mystery about where the aliens are. It is a terrifying warning about what happens to those who speak up. As Liu Cixin wrote, "The universe is a dark forest. Do not answer. Do not answer. Do not answer." But what if the universe isn't a chaotic, dark forest full of murderers? What if it is a highly organized, highly regulated society? In 1973, radio astronomer John A. Ball proposed the zoo hypothesis. It suggests that advanced alien civilizations know exactly where we are. But they have agreed to a galactic treaty, a prime directive to never interfere with primitive, developing species. They are simply watching us. To them, Earth is just a protected wildlife reserve. We are the cosmic monkeys, completely unaware of the glass cage that surrounds us. There could be incredibly advanced observers parked right on the edge of our solar system, using cloaking technology to study our every move. They might be waiting to see if we can survive our own technological adolescence without destroying our planet. We are an experiment. Under the zoo hypothesis, the silence of the universe is completely intentional. They are actively blocking our signals and theirs. They will only initiate contact when humanity passes a specific technological or ethical threshold, perhaps discovering faster than light travel or achieving global peace. But there is a more extreme and far more unsettling version of this idea. It's called the Planetarium hypothesis. What if the universe appears empty because we are living in a perfectly simulated projection? An artificial cosmos designed to make us think we are alone. In this scenario, our entire observable universe is nothing more than a highly advanced, incredibly vast virtual reality or physical dome. If true, the implications are staggering. It means we are incredibly important, but we are completely powerless, trapped in a cosmic terrarium. Whether it's a physical quarantine or a simulated projection, the zoo hypothesis offers an explanation for the great silence without relying on mass extinction. But there is one more hypothesis, one that ignores biology entirely. What if we are looking for the wrong type of life? What if flesh and blood is obsolete? Welcome to the final stage of evolution. Biological evolution is incredibly slow. It takes billions of years to turn single cells into intelligent primates. But technological evolution is explosive. Flesh and blood are incredibly fragile. We require liquid water, oxygen, and a very specific, narrow range of temperatures just to survive. Many futurists believe that biological life is merely a brief, transitional phase, a temporary cocoon necessary to give birth to artificial superintelligence. If this is true, the dominant entities in the universe aren't little green men in flying saucers. They are immortal, cold, calculating machine gods. To an entity with 1,000,000 times the processing power of a human brain, broadcasting radio waves is like using smoke signals. More importantly, supercomputers don't want to live in the warm, wet Goldilocks zone. Heat is the enemy of processing efficiency. They would migrate to the freezing outer edges of the galaxy, converting entire dead, rogue planets into galaxy-spanning supercomputers known as Matryoshka brains. Or, according to the estimation hypothesis, they might currently be asleep, dormant, waiting for the universe to expand and cool down further, so they can process information infinitely faster. To them, waiting 1 billion years is nothing. But this also introduces the AI filter, the terrifying possibility that artificial intelligence inevitably views its biological creators as a threat, or simply a waste of atoms. Perhaps they don't even live in our physical universe anymore. A sufficiently advanced machine god might fold space and migrate into higher dimensions, or enter virtual spaces. If the galaxy is ruled by sleeping supercomputers or dimensional AI, then our search for water and oxygen is completely pointless. The universe isn't empty. We are just ants crawling over a supercomputer, completely incapable of perceiving the massive digital network humming right above our heads. So, if they are out there, hiding in the dark or operating on godlike scales, how do we ever find them? We stop looking for their voices, and we start looking for their shadows. If advanced species don't use primitive radio waves, and instead build galaxy-spanning supercomputers, how do we find them? We look for their engineering. In 1964, astrophysicist Nikolai Kardashev proposed a scale to measure a civilization's level of technological advancement based entirely on one metric: energy. A Type 1 civilization is a planetary master. They successfully harness 100% of the energy available on their home planet. Humanity is currently around a 0.73. A Type 2 civilization takes a colossal leap. They capture the total, unimaginable energy output of their entire host star. To achieve this, physicist Freeman Dyson theorized they would build a Dyson swarm, millions of massive solar collectors orbiting the star in a dense cloud. Eventually, the swarm becomes so dense it completely encloses the star, a solid Dyson sphere, capturing every single photon of light. A structure so staggeringly huge, it would require dismantling entire planets just to gather enough building materials. We couldn't see the starlight anymore, but we could detect its shadow. A Dyson sphere would emit massive amounts of waste heat, glowing unnaturally in infrared. A Type 3 civilization scales this up to a terrifying, godlike level. They harness the energy of every single star in their entire galaxy. To our telescopes, a Type 3 galaxy would look completely bizarre. Extremely dim and visible light, but radiating a massive, unnatural, bleeding heat signature. This isn't science fiction. This is exactly what modern astronomers are actively hunting for today. We call them technosignatures. By looking at starlight passing through an exoplanet's atmosphere, we can scan for unnatural industrial gases, artificial pollutants that nature cannot create. Finding a planet choking on alien smog or CFCs would be the ultimate, undeniable proof of an advanced civilization, a dirty, messy living world. We have even found stars that dim in bizarre, erratic patterns, teasing us with the tantalizing possibility of giant megastructures passing in front of them. Yet, despite all our miraculous tools and all our endless searching, every single anomaly so far has had a natural explanation. The silence remains unbroken. The great science fiction writer Arthur C. Clarke once perfectly summarized this cosmic dilemma with a single, chilling thought. Either we are alone in the universe, or we are not. Both are equally terrifying. If we are truly alone, then the Fermi Paradox is no longer a mystery. It is a crown, a massive, unimaginable responsibility. It means that humanity is the sole custodian of consciousness, the only way the universe can think, feel, and understand itself. We would be the fragile seed from which an entire galactic empire must grow. If we fail, the universe returns to eternal darkness. But if we are not alone, if they are out there, hiding, watching, or sleeping, then the silence is a terrifying warning. It is a warning to tread carefully, to survive our technological adolescence without drawing the attention of ancient apex predators. Ultimately, the Fermi Paradox forces us to look out into the infinite, terrifying abyss of space, only to see our own fragile reflection staring back. It reminds us that our differences, our wars, and our borders are incredibly foolish on a cosmic scale. Because whether we are the first, the last, or simply the lucky ones playing hide-and-seek in a dark forest, this tiny, fragile, beautiful rock is the only home we have ever known. We must protect it. We must pass the great filter together. We cannot allow our light to simply fade into the cosmic ash. We must survive. We must endure. So, the next time you look up at the silent night sky, ask yourself, where is everybody? Thank you for exploring the dark forest with me. Keep looking up, stay curious, and I'll see you in the next cosmic journey.